What's going on, folks? So we're starting up a new topic, and this topic is not in our book. It's not in any other textbooks that I can find that were easy, per se, but I think that this is a really easy topic to cover. By the way, I just need to let you guys know, your final exam is a multiple choice questions. I think there's like 4 choices in this multiple choice. It's going to have, I don't know, I forgot how many problems it has, but multiple choice. There we go. I said it. Threw it out there. What do you guys think? Happy, sad, excited, scared? All right, anyway. I don't care. Yeah. All right. For this topic that we're covering, I'm going to start off with an analogy. And it's one of those analogies that I feel like is so good, it makes me one of those, this is what makes me a good teacher kind of analogy. The thing about it, I feel like, is sometimes I come up with these really awesome analogies that I really like, and I hope that it relates to, it makes sense to you, and you can understand where it comes from. And then because the s'mores analogy I thought was like the most amazing thing, and I don't think you guys really made the connection, because when you guys understand the s'mores analogy, it should have made stoichiometry cake for you guys. And I think now that after you've painfully bashed your head up against the wall to get stoichiometry into your head, now you look back and say, oh, I get what he was talking about with the s'mores example. All right? Hopefully this is not going to be one of those things. I feel like it's a really good one. Pay attention to the small, subtle nuances that I kind of talk about here in this analogy. But I think it's a pretty one straight up to start off with. Now, here's the story. I'm going to start it off with you guys. I've never seen a topic taught like this before, but let's try this. Say that you are a trucker, and being a trucker doesn't make any sense in Hawaii because there's no place to really truck to. But say that you're a trucker and you need to drive like cross-country kind of trucking. Does that make sense? All right. And here's what the deal is. All right. You're a trucker and you charge companies money for moving their stuff. And here's another thing that they have in the mainland that you guys won't understand in Hawaii, but maybe you do, is toll booths. Have you guys heard of toll booths? Do you understand what the concept behind a toll booth is? Yeah. You pay money, you're not moving anywhere. After you pay the money, you can go through. I call them a troll booth or troll bridge or whatever, because it's like a troll is collecting my money and that kind of stuff. I don't know. Back in the Billy Goat Gruff days, that's what they had. I don't even know if you guys are familiar with what Billy Goat Gruff is or whatever. Have you heard of that fable? All right, anyway, whatever. All right, so check this out. I want you guys, I'm gonna do an analogy with you. The story is gonna seem kind of weird. The math is not gonna be hard at all. And we'll go through this stuff together. I don't have a calculator on me, so you guys need to be my calculator as always. The numbers are going to be real funky. Just deal with that for now. And it's not a hard problem, okay? So, let's say that you are 42 miles away from the starting point. You need to go and pick your thing up at 0 miles over here, but you're out here at negative 42. So you bid on a product and you want to go and ship that product, and you're 42 miles away. Okay? And it cost you, you've calculated this out, it cost you exactly $4.18. Let's make it that. 4.18 dollars for every mile you go. So here's my first question to you. Is how much that's going to cost you already to get to the starting point. So you start here at negative 42 miles. You want to get to 0, and it costs you $4.18 per mile. What's the
42 times 4.18.
Good, awesome. Write that down. 42 times 4.18. Does that make sense?
4 times 42.
All right. Are we cool with that? So write that number down. Whatever you guys get, that's your answer. All right? Now, you're traveling along on your monster truck with the stolen goods or whatever product it costs to move that's so expensive that it costs you $4 a mile. And you get to the first toll booth. Got it? Now the first toll booth, which I made, I don't know, what is this troll thing, by the way? I tried looking up troll on the internet. All they gave me was this ugly face that looked like a prune.
Are you talking about like trolling someone?
I don't know. I got a bunch of trolls that look like this.
No, but are you asking like what's a troll? Like what's trolling?
I don't know. I'm wondering about what is this troll face thing.
Oh, I don't know.
I got the same looking face and it just all looked like a prune. This is
that's trolling.
This is the baby version of it.
Yeah.
But,
Video
like,
game.
all right. Anyway, I don't know what
It's like it's basically like irritating someone. You're like kind of on their back trying to bother
All right.
them
All right. So
consistently.
So here's an irritating situation you find yourself in when you're at 0 miles. Okay? You've got yourself a toll booth. They're going to charge you $334 just to get past, which sounds a little ridiculous, right? But like I said, the numbers are. Bradley's like, if you got to ask, you're never going to understand. Yeah, well, you know what? I don't care about understanding you and you kids and your crazy trolling or whatever you guys do. All right. Anyway, it's going to cost you $334. You're not going to move a single mile. You're just going to be stuck at this spot right here, and you need to start feeding in money, and all of that money, at least $334 of it, is going to go to paying off this first toll booth.
$334 to get over.
$334. I know. You're looking at me like, hey, that's a ridiculous amount of money, right? And wait till you meet the next troll. But what I'm saying is, yes, that's true. It's, $334. I told you the numbers were going to be off, but just deal with them. Got it?
Yeah.
Okay. All right. Once we pay the $334, we get to go on to the next part of our trip. So we're going to go over here from 0 miles all the way to the next city, where the next toll booth is, by the way, which is at 100 miles. Again, gas cost $4.18 per mile. So how much extra money how much money did we spend just going to the next city?
Well, it's only times 100, so it's 418.
Oh, $418.
It's times 100.
Yeah, all right, that makes sense to me.
Is it backwards?
All right, and I drove backwards, by the way.
Wait, what?
No, it's because my picture was backwards. So yeah. All right, but does that make sense?
So it's the 175.56 plus the 334.
So we're looking at 175 plus 334 plus 418 for my trip so far. All right. Now, I'll be honest with you. This second troll is unreasonable, like straight up. Here's what happens. He charges you $2,264.76 to get past his toll booth. Mind you that this is probably in San Francisco where they pay exorbitant amounts of
This
prices.
is sounding like San Francisco. Like,
Yeah.
when you first said it, I'm like,
So it's
sounds like driving over the
$2,264.74 to get across this Golden Gate freaking bridge. If you're charging me $2,000 every time I'm trying to cross, that Golden Gate Bridge better be built out of gold.
it should be.
All right. By the way, you still have another 37 miles to go.
It was 2000 what?
Oh, by the way, it was $2,264.76.
Hell, do you need 76 cents for?
Yeah, I know. If you're charging me
Whenever I
$2,000,
see that, it's like that extra little bit. I'm like, what do you need that for?
well, that's a part of the tax. But isn't this toll booth a tax in the first place? I don't know. All right. But do you guys understand what's going on here? It's like I'm stuck in this one spot. And I'm feeding in money, but am I moving anywhere? Am I going further anywhere? Answer is no. I'm stuck there until I feed enough money to give this freaking guy $2,264.76. And then after that, then I can start moving. By the way, your final destination is $37 or is 37 miles away from from that last toll booth. So figure that last part out.
Okay, wait. So after the 2,000, what was it?
You need to go another 37 miles
Oh, okay.
at $4.18 a mile, of course.
Okay.
Let me ask you this. Was this hard? If I were to give this to you on a test, just give it to you a problem like this, you guys would be able to figure that out without me having to explain all of this stuff?
Yeah.
Is that true? The guys over here are nodding their heads. I want to know what you guys think. Yeah, it's simple math. I agree with you. Not hard. All right. By the way, I had a certain size truck. Let's say that this journey also depends on maybe the mass of my truck. Would it be so crazy if I told you if my truck were twice as big, it would cost me twice as much?
No.
No, that makes sense, right?
Yeah.
Well, what I'm saying is if
Takes
your truck
twice as
is
much gas, because
right, if
it's
your
a
truck is
bigger
twice as
payload.
big, it takes twice as much gas, and let's say
It's a heavier truck.
and then the toll booths, it depends on how much cargo you're carrying. Let's pretend that. So it's $334 for every, 1 ton of cargo you have. And your first go around, you had only 1 ton of it. But let's say your second trip, you would have 2 tons, and then they would charge you twice the amount. Does that make sense?
Yeah. No.
Okay. All right.
Yeah.
Let me ask you this now. I'm gonna switch it up on you a little bit. Okay.
Okay.
Let me ask you this.
Yep.
Oh, by the way, what was your answer? I'm just curious.
$3,346.98.
$3,346.98. Cool. I don't know the answer. I'm cool with that.
Did other people get that?
Did you get 3,346?
37.
Yeah. All right. Cool. Not hard. Not hard at all. Got it. All right. Let's make up another one. All right. I'm gonna make up a different problem for you. Let's say I hired you, and it still cost all the same amount of money. Apparently, the first trip cost you $3,346, and it got you 37 miles past the second toll booth. Does that make sense?
Yeah.
Let's say I switched it up on you, and I said, I'm only going to give you $2,500. How far? Now, let's say I only give you $1,000. That's my question. I'll only give you $1,000. How far can you get on $1,000?
You can only get to
I'm assuming
the second. You can get to the first toll booth and then drive 100 miles, and then
you're going to get to the first toll booth.
and then you're gonna drive 100 miles.
Wait, you're going to get to the first toll booth. Are you going to pay the first toll booth?
Yeah.
Okay, so what you're figuring out is you'll get to the first toll booth, right?
Yeah.
And you'll drive 100 miles.
Yeah.
Oh no, you'll pay the first toll booth.
You
That's
pay
what
the first toll booth. You'll then get past it and drive 100 miles, and that's it.
And you'll drive 100 miles, and then what? Get stuck at this guy?
Well, I mean, you
can drive
but when
like
you
a
drive
little
100
bit.
miles, you get to 927
You can drive a
56.
little bit more.
Okay,
So
all
you
right.
can
All right.
drive a
Let's-
little over.
Let's pretend this. Let's say this. I didn't make that number good. What if I only gave you $900? That's my question. If I gave you $900, what I'm assuming here is that you're saying I'll drive to the first toll booth, I'll pay off the first toll booth, and then I'll get stuck somewhere in between. Right? My question is, where did I get stuck? That would be a good question for me to ask.
93 miles.
At 93 miles, how did you figure that out?
Did 4.18 times.
Does everyone understand the question and how he got his answer? The question is, I hire you, I give you $900. I say get as far as you can get on this money.
Yeah.
And you say, okay. So apparently you spend like $175 just getting there. to the first one, right?
Yeah.
You spend 334 getting past that guy, so you just go right here.
You're
You didn't go
509.
any distance.
Yeah.
With that extra 334, and you're at $509, right?
Yeah.
And then so you have like 400 or 391 dollars left over.
Because in the prior problem, you drive 100 miles and it's $4.18 per mile.
Yeah.
And you only give us $900, and by the end of that, it's $927. I just took away.
Oh, you just made it up.
I just took away $27 from the $927, and that's
Oh, okay.
That's 7 miles.
I literally would just say, okay, well, what is 381 times 4.97? No, what is 381 divided by 4.97? And that tells me how many miles I can go. Right?
Where'd you get 4.97?
Or 4.18, I'm sorry.
I just took away 7 miles.
So does that make sense to you?
Mm-hmm.
All right. This is literally how hard the problems that I'm going to be giving you are. In fact, this is a perfect analogy for the problems that we're going to be covering. I know it's weird, but is it hard? No. Okay, let me show you guys something. This is called a phase change diagram, and it's for water, specifically talking about water. We know that water at certain temperatures, so look at the axis of this graph, because this graph is exactly analogous to the story I just told you. And literally, the story that I told you actually works perfectly with this graph. This is the thing I'm trying to teach you. It's called a phase change diagram. Now, I'll be honest with you, this is a little bit in chapter 6 of the really hard textbook that we have, that I decided, I'm not going to teach that to you in their version. I'm going to teach you my version. My version works just as well. It's a lot easier to understand. All right, look at the graph. This is heat added. Think of this as energy added. Think of this as, draw this graph and think of this as money. The x-axis is money, okay? And look at this y-axis. This is the temperature of something. Think of this as miles. If the x-axis on this thing were money and this were miles, the y-axis were miles, then this picture makes perfect sense. Look, as I start way back here, as I go, what happens is, as I add money to this thing, to my trip, I will go a certain distance. I'll go up in distance. It's a linear graph. Does that make sense to you? You see that? Now this horizontal part is your first. Okay, so Tejas, check this out. Look at this graph, but for your x-axis, think of your x-axis instead of it as heat added, think of it as money. Put a $sign right there. And then this t-axis over here, this is temperature. Think of that as miles. Now this graph works exactly the way my story worked. As I start back here, I'll put in money, and as I put in money, I'll go further distances, right?
Mm-hmm.
And then this horizontal part, that's my first toll booth. So as I add money, am I going any distance? No.
No. Oh, you're told.
Right, I'm adding money, but I'm not going any distance. So
you gotta keep adding until you get to a certain point.
Then I add enough money to get to there, and then I start adding more money, and my miles increase.
Is that where you started at -42 because that's the temperature?
Yes. In this problem, I did a problem of like, how much energy does it take to raise a 1 gram of water from -42 degrees Celsius all the way up to 137 degrees Celsius? And the answer apparently is 3,346 joules. That's it.
Yeah, that's a really good analogy.
When I heard that, I
that's
thought
really effing good. Like
when I heard that, I thought
really good, Mr. Dalday.
I thought, I can think of a trucking analogy that really makes a lot of sense. Like this second one right here is the second toll booth, and it takes so much energy.
That's really good.
It's $2,000. Which actually here, let me show you a video. I want to show you this, and I want you to tell me what your thoughts are for this video. Let me see if I can.
Okay, that's
Paper cup that won't burn. Let me see if I can pull that up.
a really
Okay.
like you've had some analogies,
Some of your analogies suck.
but this one's really good.
Yeah, I've never seen people use it before. All right. I want you guys to. You guys ever make?
I've had you since last year. I want to say this is one of the best analogies you've ever told me.
Oh, good. Thanks. You guys ever make sausages on the grill?
Yeah.
You ever take like like the Portuguese sausage or something in a plastic wrap, Italian sausage, and then here's how I make it sometimes, is I don't ever drink, but I do buy a beer every so often, and the reason for that is because it's funny. I have the same bottle of wine in my cabinet that I've had since I think I got it as a wedding present, and I only use it to cook. And for beer, I sometimes make like my beer sausages, and what I do is I take, well, I'll explain it to you in just a second. But here, let me share with you this video, and since it's going to be all funky on your thing, I just chatted it with you so you guys can check it out. But here, watch this video and tell me what's going on.
1/16 something. I'm probably 1/16 black. You think they're gonna let me play Blade?
What?
1/16 black.
I don't know. All right, here. Check this out. Tell me what's going on. What do you see?
2 cups.
2
They're
cups.
paper cups,
2 paper cups
and there's fire
on a fire.
One burning, one's not.
One got toasted.
The other one's still.
The other one's not burning.
Is there water in it? Yeah.
You are currently
There's water in it, isn't there? Yeah.
Yeah, what's the deal? That's my question.
The temperatures are
The-
different.
How is the second cup not burning?
Because
water
there's
would be-
less oxygen within the first, within the second one. Because isn't there water in there? Like if there's water in there, it makes sense why the cup isn't burning.
Okay. Yes, there is water in there. You figured it out.
Okay.
Why is the cup not burning?
Because it's absorbing the heat energy.
What's happening is this number we found was absorbently huge. You told me $2,264.76. Are you freaking kidding me? Well, what's happening is
It's a high boiling point.
no, it doesn't have a high boiling point. It's 100 degrees Celsius. That's not what it is.
Or
It's
it
got
takes
a
time.
high. What this is called is a high latent heat of vaporization. That's what this number is called. That 2,264, that is called the latent heat of vaporization. Vaporization means to, what is it, when I tell you to vaporize something?
I think of Star Wars.
All right, well, I think of turning it into a gas,
Oh.
right?
Think of, like,
All right. The reason why I giggled is because I figured that you guys would turn it into a drug analogy, but if you vaporize something, you turn it, right.
Vapor. Sorry.
Right, you're turning it into a gas. Does that make sense?
I guess I'm still a kid.
So the latent heat of vaporization is the number that is attributed to turning a liquid from a liquid to a gas. Okay?
Mm-hmm.
And apparently for water, the latent heat of vaporization is 2,264. So what's happening in that video is even as you're putting in energy, as you're putting in heat, because it's on the fire, it's still absorbing a lot of energy. A lot of that energy is going off to paying that toll booth.
Vape is life.
So if there is more than 1 gram of water, it's going to take, like if there's like 10 grams of water inside of that cup, which isn't even very much water, that's going to take a lot of energy to boil that water.
Yeah.
Because that cup won't burn until all the water is boiled away.
Right.
So even if there's a little bit of water in there, so you know what, the reason why I told you about like barbecuing is because one of the techniques I do,
wonder how long it takes people to figure out what's going on with that video.
I don't know,
Like
maybe less time, maybe you got it quicker because I went through analogies like this.
I understand science, but like,
Well, what I'm saying is like,
I wonder how long it takes people to just show them a video of 2 cups that look exactly the same on a fire pit.
Cameron, your microphone is off. Cameron, Okay, you're ready. I'll log down my back end. What I'm saying here is that like a lot of your energy is going into vaporizing all of the stuff, and then your cup won't burn until all of the liquid is gone. That's what's going on. That's how to do this problem. All right. So what happens is, and you know what? I hate to say this, but I will only have enough time to go over this analogy and explain it to you. And I think on Wednesday we'll have to do a lab and explain to you how to solve problems at the same time.
Okay.
What's happening here is, or the barbecue thing. One of the things is, you know how you get the packages or the sausages in the plastic bags, or the plastic sealed whatever.
Yeah.
I take a
Are you
knife.
talking about the casing?
Yeah, no, not the casing. I'm talking about like a Portuguese sausage that's sealed in, plastic, vacuum sealed plastic.
yeah.
What I do is I take a knife and I cut off the top, or I just cut a slit down the top. I pour beer straight inside of the package, and I put the whole thing, plastic and all, straight on the barbecue.
No, that's not really healthy.
Why?
Because the plastic.
Will melt,
No. But, I mean, cooking with plastic is like really bad. Like,
but I'm not cooking the plastic.
EPA and
The plastic's not getting hot.
you're taking the can. And
I'm
you're
taking
putting
a beer can. I'm taking beer, putting it straight inside of the plastic bag with the sausage, and putting that straight on on top of the fire.
But I mean, the plastic still gets hot, right?
Does it?
Doesn't it?
Where does the energy go to?
It's gonna
The
go to
beer.
the beer, but the
As long as there's
plastic's gonna
liquid-
get warm, isn't it?
As long as there's liquid in it, the plastic won't get hotter.
But
I mean,
will
I'm not saying that you guys
temperature
should
will
just go and
increase.
be like, oh, that's easy. Let me go grab that plastic thing right off the thing. The fire.
I don't think that's like healthy entirely.
Hey, that's what I did. That's an actual recipe.
It does like I'm sure it tastes good, but doesn't
I don't know. I'll be honest with you. I don't know.
Wait, you didn't do it?
No, I did. I don't know if it's not healthy for you.
No. I was like, did it taste good?
Oh, yeah, it tastes great.
Oh, okay.
It's like beer brats.
Yeah. Well, I was thinking bratwurst.
Yeah.
Yeah.
So that's the way I've cooked it in the past. And now you understand the science behind it.
Yes.
All right. So here's what's going on. All right. In the actual problems that we will be solving, we will have energy. The energy comes in two different forms. One form is called joules of energy. And if I had joules of energy, these numbers that I gave you, 4.179, 334, these are exact numbers that are work for water specifically.
I remember doing this for her class.
For Sarah?
Yeah.
Miss Sonanini, did you do a
We
phase
did
change?
we did like
Sarah and then Miss
joules, energy and stuff, right? In physical science.
Yeah.
Yeah.
Did you do Q because MCAT?
No.
Oh.
No. If we, and it's a good review, and if we did, it's not going to be as in-depth.
Okay.
I'm just saying, I remember.
All right. Anyway, here. I've got two equations to explain to you, but the most important part is that you understand the story.
Okay.
All right? The first equation is Q equals MCAT. And MCAT should be something familiar to you guys, or at least to the three people that I have here. Do you guys know what the MCATs are?
Oh yeah.
MCATs is like the
Yeah,
SATs that you need to take for medical school,
yeah,
right?
I know because I'm gonna
Well,
hopefully take them.
actually, it's not MCAT. The way I'm going to do it is write down MC triangle T, the delta symbol.
Oh yeah, change it.
So what this is saying is your energy is equal to the mass times the C, which we're going to call the specific heat, times the change in temperature.
We did do this.
What this
Like
what this equation is here's, let me explain each part to you. Q equals MC delta T, all right? I kind of think of it as like this. The Q is like the money in my analogy. The M is the mass of your of whatever it is you have.
Yeah.
The C, that is called, and write this down, C is called the specific heat.
Capacity. Yeah.
Specific heat capacity,
Yeah,
exactly.
I remember all of this. Yeah.
And it is, for water, is 4.18. It's like your gas prices. Actually, what it is technically it's the slope of this line. That's what it is. Whatever the slope of that line is, that's what your C is. Your AT or delta T is your change in temperature, which basically is equivalent to my change in
Sorry, can you repeat what
change
C
in
again?
miles or change in distance.
What's C again?
C is your specific heat
What
capacity.
was M?
M is your mass.
Oh, right. Yeah.
So if I ask you a question like, yeah, and energy is measured in two different ways. One is joules. The other one is maybe something you might be a little bit more familiar with is calories, because this relates back to food a lot, food chemistry. So you could have joules or calories. I think if it were measured in calories as opposed to joules, this would be $1 per mile. Okay, that's really nice.
$1.
And this would be like 37, I think. Or, I don't know, I forgot what this number is.
Whenever you're $1.
And then this would be $1 per mile, and then this would be like $78 per mile. Or $78 for this toll booth.
Oh my god, where did you get these troll faces from?
I just looked up trolling online, and apparently it gave me a bunch of these weird looking
You know-
creatures.
For someone who says they don't know what trolling is, you're remarkably good at putting it together in an analogy for chemistry. Because it's pretty on point,
Yeah, okay.
like for what trolling is.
Alright, so that's my Q equals MCAT. Alright?
Okay.
There's another equation that you need to write down that I didn't give you.
And
Alright.
what's Q again?
Q is energy.
Okay.
It talks about joules. So here's one question that I could
Q
give
is
you.
joules.
Q is in joules or calories.
Okay.
So here's one question that I could give you. If you had a 3 grams of water and you wanted to raise the temperature from 2 degrees
Is
Celsius
Oh, sorry.
to 97 degrees Celsius.
Joules, J-O-U, right?
J, just put J, joules. Oh yeah, Joule is, yeah. But here's the problem: is say you had 3 grams of water and you wanted to raise the temperature from 2 degrees Celsius to 98 degrees Celsius or something like that. You would have to figure out what Q is, and using this equation, it's pretty easy. It's equivalent to me saying, "Hey, you're 2 miles past that first toll booth. How much money is it going to cost you to get to 97 miles or 98 miles?" That's the analogy, going back to that analogy, which is not hard. All right. The other equation that I need you to write down, and I don't have it up here, I'm just going to have to tell it to you, is Q equals ML.
Q equals ML.
Yes. And you use this equation, when do you use it? Well,
Mass times liter.
mass times the latent heat. Now, there's 2 times when you would use this. You would use this, the first time you would use this if you're going from a solid to a liquid. And in that case, L, for water specifically, is 334 joules per kilogram. Or per gram, I think. It's per gram, but whatever. The second time you would use this is when converting from liquid to gas. Okay? No, Cameron, I'm not saying Q equals MCAT, which is equal to ML. No, these are different scenarios that you would use these different equations.
These are separate equations.
These are separate
They
equations.
don't go hand in hand,
They do go hand in hand. They go along with this story.
but they're for different things.
Right.
Okay.
So here's what I would say. All right, check this out. What if I had a problem where I said, you have 1 gram of water, and you need to raise that gram of water from negative 42 degrees Celsius, which obviously is solid water, so it's ice, to 137 degrees Celsius. Well, here's what you would do. You would use Q equals MC delta T to go from negative 42 to 0. Then you would use Q equals ml to figure out how much energy it's going to require to go to convert all of that solid to a liquid. Then you would go back to using Q equals mc delta T again to get from 0 degrees Celsius all the way up to 100 degrees Celsius. Then you would use Q equals ml to go from, to convert all of that liquid to a gas, and then you would use Q equals mc delta T one last time to go from 100 degrees Celsius to 137 degrees Celsius. I literally just described to you the first thing we did. Just in my analogy, I use a truck.
And only addition.
And only, that's the
And
what
a
I
little
described to you.
multiplication, But you have to still like.
Right. So
But because there's these equations in between, there's still more math. But it's
no, it's still some math, but it's not even that hard
each
math.
step. Do you add it after you?
Yeah, you just add them.
You just add them.
So like, look, when traveling between cities, use Q equals mc delta T.
Mm-hmm.
When stuck at a toll booth, use Q equals ml. And the L that you use depends on which toll booth you're stuck at.
Okay.
If you're stuck at the first one, use L equals 334.
Oh,
If you're stuck at the second one, use 2,264.
So now all you have to do is identify what's a toll booth and what's a city. And what's a road.
Well, there are no cities, but the toll
Okay,
booths.
toll booths and roads.
Yeah, the toll booth and the road, where you're at, right? And here's
Well,
I'll
if there are no cities, I don't
I'll
see
tell
why
you
they're
I'll tell you
toll
the
booths.
main problem we're going to solve. The main problem we're going to solve is you have this much water at this temperature.
Yeah.
How much energy did it take to raise it to this temperature? Which is equivalent to me saying you have a water that's starting out, or your truck is 30 miles past the first toll booth. How much money is it going to require you to go this many miles? That's the equivalent of my analogy. So I think that the reason why people find this hard, and the reason why I started off with this analogy, is because they get lost with, well, which equation do I use in which situation? There's so many freaking equations, and there's so many equations in so many situations. And my answer is this: there's only two equations. And if you keep the picture in your head pretty rock solid, then knowing which equation to use is not hard.
It's just like Pervner.
No, it's easier than Pervner.
Easier because it's
No,
consistent. Like you don't have to
like in the
switch anything
sense
around.
that you have two different equations.
Oh yeah,
that
but you don't have to like switch
Yeah.
anything around.
No, you don't have. You might have to solve for M. I might ask you to solve for C, or something like that.
You might.
No, I'm sure that I will. I'll ask you. You'll be asked to solve for C or T or M or whatever. But you guys are able to manipulate these equations pretty easily, right?
I have to use her.
All right. Anyway, and just like Pervnert, I have a quick way of memorizing it. MCATs. Q equals MCAT. Q equals ML.
Just write it down.
All right. I'm past my due date or time. You guys get out of here. I gotta go. I'm leaving right now.
Thank you, Mr. Baldwin.